Oh, moving on.
Okay. Today we are starting a new chapter, chapter 5. We are going straight through this chapter, the entire chapter. It's 14 days, and we have 14 days until spring break.
That's it?
14 school days.
No way.
So, I have one issue though, and that my daughter's on the track team, and they have a regional track meet, and I wanted to go watch. And it's Wednesday the 10th, but then that would mean it pushes your test until after spring break, which would be a very bad idea.
Yeah.
So I have to figure out what we're going to do about that, but hopefully we'll get it in.
Yes, we go.
Or another project.
We got like on a code.
Yeah, it might be. Okay. So I will figure that out, but know that I will probably be gone one day. All right. So this is there's a lot going on in this chapter. We are going to spend the first few days here simplifying expressions. And these are trig expressions, but everything is basically algebra. And we're using identities to help us make things more simple. And the idea here is that this is mostly used in calculus. We, in calculus, need to be able to use our algebra skills to rewrite things in their most simple form. And sometimes that'll involve trig, and sometimes it won't. But all of this stuff you'll see in in calculus. And it's really just substitution. Trading one thing in for what it's equal to. So the first thing is the quotient identities, which hopefully you know. Tangent of some angle is equal to what over what? Sine of theta over cosine theta. Very good. Tangent theta is equal to sine theta over cosine theta. And the important thing here is that these two things are identical. And what that means is they are graphically identical. So one way to tell if you've got something done well, if two things are equal, is to graph it. Because, when in doubt.
Grab that knife.
Yeah. All right, so what I'm going to do then is I'm going to put tangent of x. So tangent of x in y1, and then I'm going to do sine of x divided by, that's not right, divided by cosine of x in y2, and what should we see? They should be the same graph. They should be equivalent. And so I'm just going to do a zoom trig, and there's tangent, toes to nose graph, goes through the origin, and now it's graphing the second one right on top. Can't see any changes, and I know that they are equivalent. So you can always check things graphically, which is what we're going to be doing for the next few days. So if you know tangent, then cotangent of theta is cosine of theta over sine of theta, and these are the quotient identities there. Again, they're on page 372. Page 372 in your book has all of the identities, even the ones I don't talk about. There are some that I'm just like, these are so arcane, we just really don't need to know them. And so we focus on the ones that I do think you need to know. So everything we talk about here, I expect you to know and love and memorize. The Pythagorean identities, there were 3 of them. The big one is sine squared of theta plus cosine squared of theta equals 1. That is the big kahuna. He's the one you need to know for sure, absolutely. Maybe in the book it's cosine squared plus sine squared equals 1. It doesn't matter what order that's in. What's important about the Pythagorean identities, now we derived these, we did this in your notes. The thing that's important about these is that you can rearrange them. And so I can look at this equation and I can rearrange it. And if I get sine squared of theta by itself, what is it equal to? 1 minus cosine squared theta. So all I have to do is move the term to the other side, and that would give me sine squared by itself. That's really, really important. And for the same idea here, I could get cosine squared by itself, and cosine squared is equal to
1 minus sin squared theta.
sine squared theta. It's not a sin, it's sine. Okay. All right. So all these things are equivalent. And what we're going to be doing today is we're going to say, oh, if I see this expression, 1 minus cosine squared, then I can trade it in for a sine squared because they're equal to one another. And so you're going to see me making little clouds around things and replacing them with things that they're equal to. So we're going to do a lot of substitution today. So that was one Pythagorean identity. The others had special little sayings. I don't know if you remember, but one adds a tan by the c. 1 adds a tan by the c. That would be 1 plus tangent squared theta equals secant squared theta. Stuff you need to know and love. If you need to write that down, 1 adds a tan by the c, then you need to do that. Now, same idea. I can rearrange this to suit my needs. If I wanted to get tangent squared theta by itself, what is tangent squared equal to? Secant squared theta minus 1. Okay, so you can rearrange, just subtracting the 1 to the other side. All right, 1 adds a tan by the c. The other, last Pythagorean identity was cot plus 1 equals cozy. Cotangent squared plus 1 equals cosecant squared theta. Cot plus 1 equals cozy. Again, things you need to memorize. Hopefully the little saying helps. Definitely write it down so you remember it. Say it yourself all the time. Cot plus 1 equals cozy. All right, as in your camping cot. So again, I can rearrange. Cotangent squared of theta would be the same as what? Cosecant squared theta minus 1. Good. So again, subtracting the 1 to the other side. So that's really important that all of these can be rearranged. Okay, so today, I heard a squeal, so you must not be done. Okay. Are you good now? See what I did there?
Good now.
Oh, not good now. No. Okay.
That's good.
Okay. All right. We're good now. All right. Example 1. Rewrite using sine and cosine and simplify to a single term. No.
Really? I'm in the videos? Oh my gosh.
Now, it's important you understand that all the things that we just talked about, the things I was just writing down, number 1 and number 2 there, I expect you to know those. I will not give them to you. You must memorize them. So please learn them fully.
What if you put the riddles on the board? Bye, Sam.
All right. Rewrite using sine and cosine and simplify to a single term. So rewriting using sine and cosine is one technique for simplifying trig expressions, which is what we're doing today and tomorrow. It's one method. We don't use it all the time, but it's a good method. Sine and cosine are the main trig functions, the big ones, the most important ones. And so one method that we do is if you have other trig functions, then you would rewrite them in terms of sine and cosine. So something like cotangent theta, I can rewrite. Using what? What can I change it into? Cosine theta over sine theta. That was the quotient identity that we just talked about. So we're using the quotient identity and trading, substituting. Instead of cotangent, we can write cosine of theta over sine of theta. Then we have multiply here. And again, secant is not in terms of sine or cosine, so I could rewrite that as well. What can I trade secant in for? 1 over cosine of theta. What is that called? Reciprocal identity. So again, these are all identities from that page, what is it, 372 or something like that? And now we have this whole thing written in terms of sine and cosine. Now, what we just did is exactly equivalent to what we started with. I could type this in my calculator. I could type this in my calculator. They'd be the same graph, okay? Now, we are multiplying fractions. How do you multiply fractions? Straight across. Cosine times 1 is cosine of theta. Sine of theta times cosine of theta, I can't really do much with that. So we write sine theta, cosine theta. Now, that was kind of a boring step. Now that we did that, what can we do? Reduce. We can reduce the cosine. Cosine divided by cosine is 1. Cosine goes into itself one time. We get 1 over sine of theta. And what can I trade in 1 over sine of theta for? Yeah, cosecant of theta. Okay. So again, back to the reciprocal identity, CIP. Okay. Do you think you could skip this step here that we did? Yeah, maybe. We can see that they would reduce top and bottom here. Do be a little bit careful with that, though. We are simplifying to a single term. Now, technically, this is a single term, but I like this answer a little bit better. It's just a tighter package. Does that make sense to you? These two answers are identical. They are exactly the same. All right. So if you got to 1 over sine, good job. If you can get to cosecant, great. I like that just a little better, just because it's more compact. Okay, questions on that? All right. So here we have directions that say multiply, then simplify. There's lots of ways we can simplify these expressions. So one thing we could do is rewrite in terms of sine and cosine. However, if you see things that have ones and things that are being squared, I'm thinking about our Pythagorean identities, and that is the second strategy when we're trying to simplify expressions. If you see things that are being squared, your brain automatically needs to think, what are my Pythagorean identities? And especially if there's a 1 in there, 1 plus tangent squared, 1 adds a tan by the secant squared theta. Okay. I'm glad you thought that was so funny. That was adorable. Okay. So when I see something like that, I can trade it in. What can I trade in my 1 plus tangent squared for? 1 plus tangent squared, I can trade in for a secant squared of x in this case. Doesn't matter what the variable is, whether it's theta or x or alpha or beta, it doesn't really matter. All of that right now is in parentheses.
So where'd you get secant from?
Because 1 plus tangent squared is equal to secant squared. So I'm trading in this whole complicated, that whole complicated expression for something really simple and compact. I'm going to bring down my cosine squared of x. These two things are being multiplied. So we used our Pythagorean identity first this time, and now I'm going to go and rewrite in terms of sine and cosine. Do I need to do anything with cosine squared of x? No, it's already cosine in cosine form, so that one's good. But what should I replace secant squared with? 1 over cosine squared of x. Good. So again, that's a reciprocal identity. Now, what happens here? It reduces, yeah. So you could multiply straight across, big cosine squared over cosine squared, but it does just reduce. Cosine squared goes into itself one time. So we get 1. Nice compact answer there. Okay. Today's work, the front is pretty easy. Hopefully it'll go nice and smooth for you. The back gets a little more challenging, and the complicated part is knowing how much work to show. All right, so please ask me if you're like, is this the right amount of work? Like, do you have to show this multiply step? Sometimes you do, and sometimes you don't. So you have to be a little bit careful. All right, last two here. Multiply, then simplify. Multiply, then simplify. What is this letter here? Alpha. Alpha, that's Greek. The Greek alpha, Greek A. Multiply, then simplify. Okay. This is the sum and difference pattern. It is the same as x minus 1 times x plus 1. It's just algebra. What happens when we multiply x minus 1 times x plus 1? You get x squared
Minus 1.
minus 1. Yeah, x squared minus 1. So a bunch of stuff cancels out when we FOIL these things together, when we multiply them together. We do the same thing with trig functions. I'm going to go ahead and multiply first times first. Cosecant of alpha times cosecant of alpha is cosecant squared of alpha. Now let me remind you, just so we're clear, it's not alpha squared, so that's a good point. So I could write this two ways. Cosecant of alpha quantity squared is what it technically is. It's cosecant of alpha times cosecant of alpha. That's that. But we shorthand it and say cosecant squared of alpha, so we can write it without the parentheses. It is not the same as cosecant of alpha squared. All right, alpha squared, that just means that alpha is being squared, not the whole trig function. So that's really different, okay? So this is cosecant of alpha times cosecant of alpha, which we shorthand to cosecant squared, squaring the entire thing. When we multiply the outside here, cosecant of alpha times 1 is cosecant of alpha. I can distribute the negative 1. Negative 1 times cosecant of alpha is negative cosecant of alpha. And then last times last, negative 1 times positive 1 is negative 1. And what happens now? Yeah, the positive cosecant alpha and negative cosecant alpha cancel out. So then the question, and this is the question that most students run into, do I have to show that step? No, you don't. Okay, at this level, I think that you can multiply this in your head and get right to here. Okay, I'm showing it because this is notes. And so now that we're talking about it and we all understand, you can go straight to here. If it's the sum and difference pattern, careful if they match. Okay, be careful. Jake. Oh, good thinking. Yes. What's the one more step here. Pythagorean identity, we have things being squared with 1. So let's see. Cot plus 1 equals cozy. Cotangent squared plus 1 equals cosecant squared. Now, these don't quite match. Yeah, if we move the 1 over, we would have cotangent squared equals cosecant squared theta minus 1. And now what can we trade in our cosecant squared minus 1 for? Yeah, cotangent squared, in this case, alpha. So thank you for that. I appreciate that. One step further. Condense it as far as you can. So looking out for those Pythagorean identities, very, very good thinking. Thank you. I wonder if I did that first period. I can't remember. All right, last one here. These on the back of your worksheet today, we get into some adding of fractions. What do you need in order to add fractions?
Common denominator.
Common denominator, right. And the same is true when we're adding trig expressions, okay? So these are just fractions, but they have trig in them as well. And we need a common denominator. So here I have a denominator of 1 minus sine of x, and I have this other denominator of cosine of x, and we need everything. So on this first fraction, what do I need to multiply by?
Cosine of x.
Yeah, so I'm going to multiply top and bottom by cosine of x, and I encourage you to squeeze it in. Smush it. And what does the second fraction need? 1 minus the sine of x. Again, on top and bottom. Be careful when you're doing this today because it's different in the homework. A little trickier. All right, so now I have a lovely common denominator that is cosine of x times 1 minus sine of x. And in general, we want to leave these things factored. I don't want to multiply it in. That looks more complicated. But also, we want to leave it factored like it is so that we can cancel if we need to. Factor and reduce. Now, let's look at the numerator. Cosine of x times cosine of x is what?
Cosine squared.
Cosine squared of x. Good. We have a big plus sign. And now we have to multiply these two bubbles together. This is the sum and difference pattern. So that's good. So what do we get when we multiply it? 1 minus sine squared of x.
Sine.
Thank you. Again, the outside negative sine of x and positive sine of x cancel out. So we don't have to worry about those. Now, again, I'm thinking identities. I'm looking at 1 minus sine squared x. That's a Pythagorean identity. What is 1 minus sine squared of x the same as? Cosine squared of x, that's right. So I'm going to trade that in. So I have cosine squared of x plus, and I'm trading in 1 minus sine squared for another cosine squared of x. Yeah, so 1 cosine squared of x plus 1 cosine squared of x is 2 cosine squareds of x over our denominator. All right, and then what do you think you can do? Can you reduce it? Yes, you can reduce it. This cosine squared of x is really cosine of x times cosine of x. So we've got a cosine of x on top and a cosine of x on bottom. And you can reduce those. And that's going to leave a 2 on top with a cosine of x to the first power. And then just 1 minus sine of x in the denominator. For us today, this is about as good as it gets. I think the ones on your homework clean up a little bit better. But this is a good final answer. Is it more simple than what we started with? Yeah, it's more simple than what we started with. It's a single fraction, so that's good. Jay.
But the denominator can be cosine of x.
No, it cannot. That is a very good question. So Jay asked the question, can the denominator be cosine of x? And that's a really good question. We know that 1 minus sine squared of theta is equal to cosine squared of theta. The question is, can we take the square root of both sides? And is that 1 minus sine of theta equal to cosine of theta? So this is the question. Are these two things equal? No. And so you can prove it to yourself. This is a great thing that you asked. 1 minus, sine of x is supposed to be equal to cosine of x. So if it's true, what should we see? They should be the same. Yeah, overlapping graphs. So here's 1 minus sine of x. Oh, there's cosine. Same or not the same? Definitely not equal to one another. And so you cannot take square roots of those Pythagorean identities. All right? That's a really good question. Do you guys have any questions for me? All right. It is homework 30 tonight, class practice 30.